Hey folks, welcome back to another new episode of video series on Linux kernel compilation. In this episode, I would like to show you how you can custom compile a Ubuntu kernel in Ubuntu desktop as well. So you can download the Ubuntu kernel using a command prompt, and then once it is downloaded, it is automatically going to apply the patches and make it as the latest release which is existing in that specific distribution as well. So we can do that in the command prompt, and then once it is done, you can borrow the kernel's config file from the existing Ubuntu kernel which is booted and it is running, and you can use the config file, and I can show you the various steps involved in terms of basically how to start with from here, and once it is compiled, how you can install the kernel deb files, and you can boot into your newly compiled kernel, and you can start using your compiled kernel as well. So let's just walk you through these steps. Let's just hop on to my desktop. So guys, here is my Ubuntu desktop. I can actually compile the kernel inside this desktop itself, but only the problem is once I try to reboot the system, I can't anymore capture the screen directly via screen capture software. For that, as you know, it needs an operating system. So I can miss in terms of capturing a better video of grub bootloader options. So for that, I need to grab my camera, and capturing a screen via camera is a kind of bad option. So there is another alternate way. I think it is best. It is going to be via virtual machine system. So before shooting this video, I have written all the steps which is necessary to compile the kernel in the Ubuntu way, so that I don't stumble upon and miss any steps, and kind of waste the time as such. So here are my steps. So, and before shooting this video, I kept ready a complete Ubuntu install in a virtual box, virtual machine. I have usually have this Ubuntu 15.04 VM, which I have cloned into a new VM so that I can have a fresh system. Actually, this is a fresh Ubuntu system with almost like no extra modules installed actually. So immediately once you install the Ubuntu, whatever you get is the same thing which is going to be here. And couple of times I have of course updated the packages which are installed, but other than that, this is a fresh Ubuntu system. So guys, let's just boot the system, and it has all the configuration which is set up and kept ready. So here is my bootloader screen. As you can see, you can just check what are the installed kernels inside this Ubuntu system. So you have some of the old kernels like 3.19, 22 and 23 and so on, and it's been around a couple of months. I have not updated any software packages. So first thing I'm going to do is boot in the system. You can almost assume that I'm doing this directly on my desktop or laptop system. So you can just forget the fact that it is Ubuntu installed in a VM or something like that as such. For the sake of video, I'm just shooting in a VM system as such. So let's just boot in this kernel. So this desktop, it is having an SSD drive, and this VM is also of course running on SSD drive. So that's the reason it just boots almost incredibly fast. So here is my system which is just booted. Since it's been quite a long time, I think it is better to update the software packages. You can just do apt-get update and things like that, but I prefer doing it via graphical tool. Okay, so we can use something like this software updater GUI tool. So I sometimes prefer using GUI tools extensively than command prompt variants as such, so that this gives a better visibility, and it is much more professional sometimes I feel doing things in Linux as such. So I just want to show you real time, like the complete experience, the way you compile the kernel as such. So I can of course skip these things, but if you are really new into Linux operating system basics, and on top of it you may be an expert in system software development, but you may be completely new in entire Linux operating system experience. So I just want you to not miss any of the fundamentals. So these are the modules which it is supposed to get updated. Let me just click this install now. Of course I am going to skip this video for a while, so that you can just authenticate. So I am just going to leave this for a while, and once it is almost done, I am going to restore the video. So let's just you can see that it is downloading the updated packages. See, you can see here it is downloading the latest kernel, which is 3.19.0.28. So it is going to install this latest kernel, and I should able to get around 3 kernels effectively installed in this Ubuntu operating system. So let me just it will take as you can understand, it is going to take a while. So let me just skip this for a while. Let me just disconnect this video, and then I'm going to reconnect once it is fully updated the system message. So here is the system, guys, and it has downloaded all the software packages, and now it is installing those packages and updating the older ones with the new ones. So this again going to take a while. Let me just wait few minutes. I think you can just see the complete flow as such. I think this is going to take just a couple of minutes or something like that. So after this I am going to boot the system, so that I can show you the at this point of time what are all the kernels which are installed in the system as such. So it is installing the Linux kernel. Yeah, it has updated the bootloader. You can see here it is having totally 3 kernels now. Let's just wait for a couple of more minutes to get this done. Yeah, so this step is complete. So now we have a system which is fully updated. We can just restart the system. I'm going to press this restart now button, so we can just restart. Yeah, now we are in the grub bootloader. So once you verify this, now you can see there are totally 3 kernels, 3.19.0.22, 3.19.0.23, which existed earlier, and this new kernel which is 3.19.0.28. So let's just boot in this new kernel. Okay, let me just open this shell terminal, and you can just verify your booted kernel with uname -r. So it shows 3.19.0.28, so we are perfectly fine. So what you can do is you can just create a folder or something like kernel compile or something like that. So pwd, we are in the home location, so I can just do mkdir kernel build, so ls. So we can go inside this folder. In this folder actually we can download the Ubuntu kernel source and then start building the same as such. So let me just go back to my guide. So what I have done is, this is the step I have done first. So I have done the entire system update, and this is a optional step where in which you can define the number of threads, simultaneous threads you want to build during this kernel build. Actually this command actually corresponds to step of this asset. So this tells that I need totally 4 threads to be executed simultaneously. So I can just anyway type this right away, or else I can just type this after some time. So anyway, since it is not a high priority, let me just skip this step. Okay, so since in terms of building the kernel you need specific packages, okay, things like that. So since the kernel is going to be a tarball, you need a package to untar it, and you need this duplicate tool to download the kernel source and other related packages. So let's just first install these tools. Sudo apt-get install. Okay, build essential. Build essential kernel package lib n-curses 5-dev. You need the n-curses library, so that when you do make menu config, you need the n-curses interface to be up. So for that reason we are using this. Otherwise this is little bit optional as such. And then you need this fake root tool, wget and bzip2. Fake root, wget, bzip2. So let's just install these. Yeah, you can confirm yes. So once this is done, in case if it is missing any other packages down the lane, you can install. That is not a big issue. I think it should have the GCC compiler. You can just verify in another terminal. GCC. Yeah, GCC is installed, as you can see. So that is we have the C compiler, which is GCC installed in the system. So almost we are good to go. So inside the VM, the transfer rate is a little bit slower, unlike the host system. So that is fine. Actually, my network is much faster as such. So it also depends on your, the speed of the server which it is connected and things like that. Actually, so I'm just again going to a little bit skip this video, so that I think this is going to take a while as such. So let me just skip this video and then come back once it is fully done as such. So guys, after a long time the modules are finally installed, and meanwhile what I have done is I have also removed the old obsolete kernels actually. So before proceeding, what we can do is, once we can just restart the system, so that or else I can suggest, once we can shut down the system, and I can fine-tune the virtual box settings, so that since we are compiling the kernel, we can increase the number of processor cores and things like that as well. So let me just shut down the system for a while. Okay, now the system is powered off. Before we kind of start downloading the kernel and start compiling the kernel, we can just evaluate the system parameters, since it's a virtual system in my case. So the RAM I can allocate somewhere around 6 GB or something like that, and I can just allocate the processor memory somewhere around processor cores somewhere around 4 cores, or say maybe even you can give around 6 cores actually. Yeah. So then apart from that, I can also kind of increase the display video memory somewhere around 60 MB, something like that. So I think these settings are good enough to go. Let me just save it. So we can just boot it now. So let me just show you the kernel which is installed. I have removed other obsolete kernels. So let's just boot with this kernel. Okay, now we are inside. Let me just open the terminal. So as you remember, I have created a folder called kernel build. Let's just get inside the folder. So in this folder we can just get our kernel sources. You can just all you need to do is you need to get the kernel source with this name as such, Linux image and the version as such. So what I am doing is Linux image hyphen uname minus r is the overall command, so that derives the entire kernel name. So instead you can even just manually do uname minus r. So this is the current booted kernel version. So you can just do apt-get source linux hyphen image hyphen, you can just add this version. So let's just get the source. So please bear in mind, don't do this in with the sudo option, and in case if you do that, the entire source code will be in the root permission, wherein which it will be later difficult to proceed as it. So just to do it as it is. Many of the apt-get commands you may be quite used typing with sudo as such, whereas in this case we are just getting the kernel source. Actually, you don't need a sudo access as such. So you can just optionally type this way like I did manually, or you can even type this way as such, Linux image and then uname minus r. This will always ensure it will get the kernel source of the current booted Ubuntu kernel as such. So what happens is once it is downloaded the kernel source, it is going to get the vanilla kernel, which is the kernel source from kernel.org, and then it is going to get also the Ubuntu patches, and it is going to patch the kernel, and then it is going to create the entire kernel source directory for you as such. And this is the advantage of using something like Ubuntu kernel versus kernel.org kernel as such. Kernel.org kernels are highly generic kernels, wherein which it may miss some of the very important vital device drivers and some of the patches as such. So that's where the Ubuntu kernel comes handy as such. So Ubuntu kernel is very much full-fledged, and it's well maintained, and it is of course they get the kernel.org kernel, and then they apply all the relevant patches, and then they produce the kernel source as such. Yeah, now the kernel is downloaded. You can just ignore these warnings, that's fine. So as you can see, it has got this kernel source, and it is applying the patches. Let me just scroll a bit up if I can catch. I'm sorry, I think okay, yeah, it is there. It has got the kernel source, and then it has applied all these patches as such. So now let's just see what the directory contains. Yeah, as you can see, it has two tarballs. One is this kernel source, and this is the patch which it has applied on top of it, and before applying it has extracted and then applied this patch. So effectively you have this entire kernel source in this folder. You can just go inside and confirm you have all the kernel source folder. So you can see it has the entire kernel source. Just you can go back, and this is some step which I often do, so that to distinguish, really this is not really just Linux 3.19.0 kernel as such. It is actually Linux 3.19.0 kernel which contains Ubuntu patch actually. So effectively it forms a kernel called 3.19.0-28 as such. So you can just optionally just rename this folder Linux 3.19.0 to Linux 3.19.0-28 in this case as such. So in case if you are working on some other version of kernel, you can just do it accordingly as such. So this is a step which I always do, so that to distinguish that this particular folder is really it's a Ubuntu kernel. Sometimes you can even use the name as -Ubuntu or something as such to distinguish. So let's just get into this folder. Let's just type ls-la. As you can see, it is actually missing the .config file as such. I will take another exclusive video on kernel customization and during compilation of the kernel as such. So in that I am going to cover extensively about .config and make menu config options and things like that as such. So in this case I just want to show you how you can proceed further as such. So all you need is a kernel .config file, and you can borrow it from the current booted kernel from the boot folder. It will be in a file called config the kernel version. So config -3.19.0-28, which contains the entire .config file. So you can just borrow this as the current .config file. So now you do ls-a, you will find the .config file. So now what you can do is you can just do a dummy make menu config. So as you can see, in case if you miss the .config file, it is going to throw you some sort of warning and stuff like that. So in the make menu config, once you get inside, you can actually choose various options. Say for example, you can cross check what processor it is selected as such. So in case if you are compiling for Xeon or something, you can select which processor you want and things like that actually. So once again I am going to cover this exclusively in a separate video about .config and make menu config options and things like that. So for now let's just skip this portion. So you have the .config file which is ready, and it is borrowed from the current working kernel as such. So you can just go ahead and start compiling this kernel. But anyway, before that what you can do is you can just do make mr proper. This is going to do some amount of cleanup as such. So I have written some more additional stuffs in case if I work on Traffic Squeezer, I do my Traffic Squeezer source code merge and things like that. This again going to cost me some amount of time as such before I just go ahead and compile the kernel as such. So let's just do make mr proper. Yeah, as you can see, it is just going to do some cleanup as such. This is really optional in this specific case as such. You may need it in different cases as such. So let's just not much worry about it. Once again I am going to cover these options about customization of the kernel as such. So now we are good to go. We can directly do a compilation of the kernel. There are various ways how you can do compilation in a different distribution and different scenarios actually. In a case like when I was using Fedora core kernel compilation, you can just do make install make and then make install and make modules install and things like that. Whereas in this case you can just create directly kernel binary files as such. So you can just use this tool called as fake root. So you can just use fake root make kpkg -kpkg. Usually I write this entire thing in a script as such. I never type it manually in this fashion as such. So I really don't remember this entire command sequence actually. Initrd -init. Okay, you can just use this optional parameter. This parameter tells if you want to add any specific version or something to this kernel as well. So in case if I compile for Traffic Squeezer, I substitute this ABC with Traffic Squeezer, and I substitute this sequence with the Traffic Squeezer specific version as such. So in this case, I just want to show you as for demonstration purpose, I just want to include this parameter, or else you can actually skip it as such. But you need to distinguish which is your custom kernel versus which is your Ubuntu provided kernel as such. So for that sake, let's just add this string - append to version equal to abc abc.x.x.x, or else abc there is a specific nomenclature about using this. You can't use some of the special characters and things like that as well. So I don't much remember which character you can use and which you may not use. There is a specific guide, you can just follow this parameter. So next you can type kernel image and kernel headers space kernel image space kernel headers. So effectively what is going to happen is, once this command is successfully completed, it is going to create two .deb files, which is Ubuntu deb files, and as you know, the deb files is a nomenclature which is existed from the Debian world actually. So since Ubuntu is a fork of a Debian project actually, still it has these deb files as such. Whereas in the case of Red Hat, you have the RPM files as such. So you can just do this. I think I have done some typo. Let's just verify. Sorry. app and this really effectively starts your kernel compilation. So this may take around 40 minutes or something like that as such. So let's just let me just disconnect this video, and once it is almost going to complete or something, I can just start again capturing the video as such. So what effectively it is going to do is, it is going to compile all the kernel modules which are enabled in the .config file, and it is going to finally create the kernel binary, and then it is going to effectively create the deb files which you have just now provided in the fake root command as such. So guys, after a while, here is the progress, and it is compiling various modules, as you can see, and currently it is compiling these device drivers actually. So what it is effectively going to do is, it is compiling these ACPI power supply drivers, and then it is going to compile almost like alphabetical order as such. So I think I have not enabled the export concurrency level. Usually, as I said earlier, I usually maintain a script which contains this and this all together bundled in a script as such. So in this case, since I am doing it manually to demonstrate you the overall process, I think this I have missed. So I can just cancel the compilation, or else in other words I can interrupt. I can just type this, otherwise it will take a very long time. So I can just type export concurrency currency underscore level equal to. So in a case, if you have a laptop, you can give somewhere around 4 or something. Since my system is a full-fledged desktop, I can almost give even up to 6 threads actually. So this environment variable is set. Now I can just restore the kernel compilation once again. So you can just retype this command. Nothing is going to happen. Once again, it is going to check from where it has kind of stopped, and it is going to restore from that point as such. So this time it is going to compile much faster. So let me just once again interrupt this video feed, so that I can just once again start taking screen capture once it is almost about to complete the kernel compilation as such. So here it is, guys. Finally it has compiled the kernel. Actually I was shooting this video last night, and since it is quite late, I went to bed, and sometime around half an hour before, I just started again, and then finally it has finished the compilation. So this took for a while to get complete. So once it is complete, as you can see, it is displaying the files it has created. You can just go inside this folder. It will just create the dep files, the outside folder of this Linux kernel source as well. So now you can just install these dep files using sudo dpkg -i linux -image linux -headers actually. So just install these two dep files. So it will install this in the grub bootloader, and in the boot folder as such. Usually I shoot my videos quite late night, so that it won't it will get very good audio quality as much as possible as such. So yeah, so you can see now it has this new kernel which has our name. You can just forget about this nomenclature, because this has a specific guidelines you need to read about it as such. So to give the options in the fake root command as such. So the fake root command have some more additional options where you can precisely give your own version details and things like that as such. So you can just ignore that for now. And what we can do is, since we just installed with the custom kernel, we can just reboot this system. Let me just reboot it. So we can just boot in our currently custom compiled kernel as such. So go inside it. So you can see this is the default kernel which is installed in the Ubuntu, whereas this is our custom compiled kernel as such. So let's just boot with this new kernel. Sometimes you may get compilation errors, and sometimes you may have some kind of booting issues as such. So this, if it so happens, you need to investigate what could be the reason. and sometimes booting errors can occur due to some sort of device driver issue and things like that. So here it is, guys. We just compiled the entire kernel, fresh kernel, and we just booted in our own compiled kernel. So you can just confirm with the uname command. So you can see it is booted with this custom compiled kernel. So this is the way you can compile the kernel in the Ubuntu way. So there is also a generic method where you can compile the kernel and install it as, but this is a typical way you do it in Ubuntu. So where in which you get these deb files. These are the binary files as. So suppose if you are sharing this custom kernel to a friend or something, you can just share these deb files. You can see it will be around ls minus lh, it will be around 44 MB is this Linux image and 7.2 MB is this Linux headers access. So overall it's around 50 MB in size actually, the binary file as such. And make sure also when you compile the kernel you have somewhere around 20 GB of free space in the hard disk. So in this VM I have created disk space around 30 GB, and this is a basic Ubuntu install and this compiled kernel in that actually. So totally it has used around 18 GB. So make sure you have at least around 20 plus GB of entire disk space as such, so that you have sufficient amount of space left actually. So once it is actually compiled, this folder is going to little bit bloat up, and this will occupy several GBs actually. So make sure you have enough disk space actually. So that's all folks for this episode. I hope you guys enjoyed watching this video. Please do subscribe to this channel, and if you have any queries, post it across YouTube comments, and so that I can get back. And if you in case looking for any specific corner cases for me to cover, I can cover those cases. And in my subsequent videos I am going to shoot about how you compile kernel in Fedora distribution, and then followed by how you can compile a kernel in Raspberry Pi device actually. So I hope you liked watching this video. Thank you.